Now we are going to discuss on three-dimensional shapes. In our day-to-day life, we can see different kinds of shapes around us, right? When you look at something empty, like a box or a bowl or even a room, you can feel there is some space. We can keep things inside that space. Yes? So suppose a park, you get some space to play there. These three-dimensional shapes or the figures occupies a fixed amount of space. So these three-dimensional shapes, we can call it as solids also. So what is a solid? An object that has a fixed shape and size is called a solid. Solids occur in different shapes, and these shapes are only known as three-dimensional shapes. So two important points I told right now. An object that has a fixed shape and size is called a solid, and these solids occur in different shapes, and those shapes are known as three-dimensional figures or shapes. Here you can see various types of three-dimensional shapes. This is a cube, this is cylinder, this is cuboid, this is cone, and this is a sphere. There are some more types of three-dimensional shapes also. But around us in our daily life, we get so many things which resembles with this kind of figures. Think of a dice. It's just like a cube. If you think of the gas cylinder of your house, it's nothing but a cylinder. If you look at a brick, it looks like a cuboid. When you play with a football, it is nothing but a sphere. And even when you eat ice cream, like ice cream cone, that is also a cone. So around us, we get to see these kind of figures. Slowly we will discuss about these figures. As we have started with the three-dimensional shapes or figures, can you tell me that what are two-dimensional figures? Two-dimensional figures are having two measures, that is length and breadth. Yes? What are the examples? Like square, rectangle, triangle, circle, all these are two-dimensional figures. Yes? Now can you tell me how many dimensions will be for a three-dimensional figure? The name itself is enough to answer because three-dimensional figures, so it will have three measures. What are those? Those are length, breadth and height. Examples of three-dimensional figures you got enough. Cube, cuboid, sphere, all these are example of three-dimensional figures. So two-dimensional figures are having two measures, that is length and breadth, whereas three-dimensional figures are having three measures, that is length, breadth and height. Before discussing about 3D solids, we need to know what are the elements of 3D solids. The elements of 3D solids are face, edge and vertex. What are those? Face, edge and vertex. So what is a face? The flat surface of the solid is called a face. The flat surface of the solid is called a face. We will take an example. It will be very much clear to you. Let me explain first what are those face, edge and vertex. Now, when two faces meet along a line segment is called an edge. I am repeating one more time. When two faces meet along a line segment is called an edge. And finally, three edges meet at a point is called a vertex. So when we take a solid, always we will find which is the face, which is the edges, which is the vertex, and we will count also how many faces, how many edges and how many vertices are there. So if you want to count, you need to know which is the face, which is the edge and which is the vertex. So what I told, the flat surface of the solid is called a face. Where two faces are meeting, along a line segment is called an edge, and three edges meet at a point. That point will be called as a vertex. Let's take an example. Now I will draw a cube. You can draw with me. Use a scale and pencil and draw it in your geometry classwork. Look at here, I have drawn one square, one more square like this. I have joined one corner and one more corner also. So here on the top you can see one flat surface. Can you tell me what is this? Just now we have explained elements of 3D solids. So according to those definitions, it is a face of a cube here. Now I have joined one more corner. So here also you can see it has formed one more face. Here I have joined these two corners also. You can see one more face. These red arrows are showing here one face, here one face. Yes? Can you tell me how many faces are there for a cube? Here on the top, bottom, on the left side, on the right side, front and back. So there are 6 faces for a cube. Now try to find out an edge. 2 faces meet along a line segment is called an edge. 2 faces. Here you can see I have pointed one edge. This front, this face and this side face, they are meeting in this line segment, so that is an edge. So try to find out how many edges are there for a cube. So 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 edges for a cube. Finally, you try to find out a vertex. What is a vertex? 3 edges meet at a point. Look at here, this point. Here, this edge and this edge. These 3 edges are coming and meeting in this point, so it is a vertex. So how many vertices are there for this cube? 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 vertices for a cube. As we have discussed about the faces, edges and vertices for a cube right now, so you can say that a cube has 6 faces, 12 edges and 8 vertices. As it is a cube, all the 3 dimensions, I mean the length, then breadth and the height will be equal. So in a cube, all the 3 dimensions are equal. So length equals to breadth equals to height. Can you give me some examples of cube? I have already discussed. Look at here. So like ice cubes, sugar cubes, dice, all these are examples of cube. Now we will discuss about cuboid. So here I am going to draw a cuboid. You can follow me. Draw a rectangle like this and one more like this. Join the corner here and one more. Down you can see here one and here is also one. Please join these 2 corners also. Now try to find out the faces, vertices and edges for this cuboid. These 2 red arrows shows 2 faces. You can also show any two faces. I have showed one edge and one vertex also. Now tell me how many faces are there for a cuboid. It is same like the cube only. So top, then bottom, then left side, right side, front and back. So there are 6 faces. Edges, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many edges? 12 edges. And vertices? There are 8 vertices. So 1, 2, 3, 4, 5, 6, 7, 8. So we can say that a cuboid has 6 faces, 12 edges and 8 vertices. It has rectangular faces. So in a cuboid, all the 3 dimensions need not to be equal. Yes? And some of the examples of cuboid is a matchbox, a brick, a book, an almirah. All these are examples of cuboid. Now we are going to discuss on cylinder. So I hope you all can draw a cylinder very easily. Yes? So you can draw with me. It has 2 circular faces. Join those 2. And it is taking a shape of a cylinder. So on the top and the bottom, these 2 are circular surfaces or circular faces. And it has a curved surface. What is that? Around this, if you take a round, if you touch the surface, and that is a curved surface. So one is curved surface and other 2 surfaces are circular faces. So it has total 3 surfaces. It doesn't have any corner or vertex. So a cylinder has 3 surfaces. One is curved surface and other 2 are circular faces. It has no corner or vertex. What are the examples for cylinder? It's like a circular pipe, test tube, a gas cylinder, a tube light. All these are examples of cylinder. Now we will discuss about a cone. So look at the drawing here. You can draw with me. I have taken 2 line segments and that has been joined with a circular base. So it is nothing but about a cap. Yes? So a cone is having base as a circle and it is having a curved lateral surface. It has one vertex on the top and one curved edge where this lateral surface and circular bases are meeting. So a cone has a flat circular base, you can see here, and one curved lateral surface. So it is having one vertex also on the top and one curved edge also. So we can say that a cone has a flat circular base, a curved lateral surface. It has one vertex and one curved edge. So the examples are very common to you: an ice cream cone, a clown's cap, or a carnival tent. All these are examples of cone. Look at this figure here. It is a sphere. A sphere doesn't have any vertex or edge. It has only one curved surface. So the example of sphere is very common. It is a football or a ball or a globe. Look at these pictures here. All the pictures are of a taxi. Can you tell me, are they same? No, they are not same. Why? Because though it's a taxi, but the pictures are taken from different directions. So the first one, we can see one side of the taxi. Here, the top of the taxi. Here we can see the front of the taxi. Here you can see the back of the taxi. So we can see the same taxi from different directions, and for that reason it is appearing different. So this is nothing but the different views of the same taxi. Here you can see the picture of a teapot. All the pictures are of a teapot, but they are not same, because the pictures have been taken from different directions, and that's why they are looking different. The first one, you can see it is one side of the teapot. Second one, we can see the front of the teapot. Third one, we can see the top of the teapot. And the last one, we can see that the picture has been taken in a certain angle. So depending upon different views, the object is also looking different. And we need to classify these views also. So when we are looking at the front, suppose this green shaded one, we can see here the object only the front part, and that view we can call it as front view. When we can see the side of the object, we can call it as a side view. Or when we can see only the top part of the object, we can call it as a top view. As we have discussed right now, there are three main views. The first one is front view. We call it as elevation also. What is that? When we see the object from front. So front view is known as elevation also. And what is that? When we see the object from front. Next one is side view. What is that? When we see the object from left or the right side. I am repeating one more time. When we see the object from left or right side. And third one is the top view, which we call it as plan view. Top view is also known as plan view. So when we see the object from the top, that view will be called as top view or plan view. So the main three views are front view or elevation, side view, and plan view or top view. As I have discussed the different views of an object, now we will work on that. So what you will do, you will draw a table keeping the heading like this. The first one is name of the shape, second one figure of 3D in 2D, third one front view or elevation, then side view, and the last one is top view or plan. So please draw this table and slowly you will work with me. So first shape I am taking as cube. In the column of figure of 3D in 2D, we will draw the 3D figure on this plane. That's why it will come in 2D. Yes? So please draw the diagram of a cube. Next, what you have to do? Front view. What will be the front view for a cube? You know, all the faces of a cube is a square. So if we try to find out the front view, it will be nothing but a square. So front view or elevation will be a square for a cube. If we look at the side of a cube, that is also a square. So we can draw a square for side view. If you look on the top, that is also a square. I hope you have understood. Now we'll go for another shape. So please work out with me. Here I have taken cuboid. So figure of this 3D in 2D, we'll draw a cuboid. So draw this cuboid. Now you have to find out the front, the elevation, then side view, then top view. So you can see the front view is nothing but a rectangle. So finish off drawing this much. Next we will think about the side view. If you look at the side of a cuboid, what is the shape here? That is also a rectangle. So please draw a small rectangle here. And what about top view or the plan view? Top of a cuboid, that is also a rectangle. So here we have drawn the front view, side view and the top view of a cube and a cuboid also. Please continue in the same table. Here the shape I am taking as cylinder. So you have to draw a cylinder here. Now you have to decide the front view, side view and the top view for the cylinder. If we look the front part of the cylinder, how does it look? It will be in a shape of a rectangle. So the front view or the elevation will be a rectangle for a cylinder. If you try to find out the side view of the cylinder, that will also be a rectangle. And on the top, it looks like a circle. Yes? So the front view of a cylinder is a rectangle. The side view for the cylinder is also a rectangle. And the top view will be a circle. Now I am taking the shape cone. So please draw a cone here. We will find out the front view, side view and the top view for the cone. So the cone from the front, it will be nothing but a triangle. So front view, we will draw a triangle. Even for the side view, it is also a triangle. And the top view will get a circle. So the front view for a cone is a triangle. The side view for a cone is also a triangle. And the top view will be a circle. So please complete it. Here you can see 3 figures. These are the different views of the same object. I am giving you the clue so that you can identify easily. So these are different views of the same object. You have to identify which is what. Means which is top view, which is side view or which is front view. Go for the first figure, this one. Here you can see 3 steps like this. So from the front, if we look, we will get like this kind of view. So you can understand this is the front view. Now go for the side view. So side view means you have to look from the right or the left side of the object. So here 3 steps, 1, 2, 3. Here also 1, 2, 3. So in the figure V, it is given the side view. Now if you look from the top, you have to imagine that your eyes are on the top of the object. So what the view will be, it will look like this. So the first one is the front view, second one is the side view and third one is the top view of the same object. Now we will construct solid figures from networks. So before the construction, we should know what is a net. In geometry, a net is a 2-dimensional shape that can be folded to form a 3-dimensional shape or a solid. I'm repeating one more time. Please listen carefully. A net is a two-dimensional shape that can be folded to form a three-dimensional shape, and that is nothing but a solid. So we will construct nets and you will get to know how we are using a two-dimensional shape and folding it and forming a three-dimensional shape. Let's start the net of a cube. So to construct the network of a cube, what you need a plain paper, plain white sheet you can take, your scale or ruler, a pencil and a scissor. So first you will observe, listen carefully, then you will work. So on the plain paper, you will draw a diagram like this. Now you can see there are 1, 2, 3, 4 continuous squares. And here 1, 2, 3 squares, they are sitting vertically. This purple one is the common one for the horizontal and the vertical arrangement. I have colored these 4 squares in orange and these 2 in purple. You can do also. After drawing this part, with your scissor, neatly cut on the edges. You can see the edges. As my pointer is moving, the outline, the boundary of the figure, you will cut with your scissor neatly. After cutting, we will fold the paper. Look at here. Before folding, please mark it like S, 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 all the 4 orange squares, and the purple, the center one as B, and on the left, extreme left, it will be T. S will represent all the 4 sides of the cube, B for bottom and T for top. Clear? As I have told, we have to fold the paper. Look at here, the dotted lines. We have to fold along with the lines. So here one folding, here one folding, here one folding, here one folding, and here is also one more. In the same direction means when I am folding this B and S in between this line, this square will come upward. Here also along with this line we will fold and this square will come upward. So here also you will do one more folding. This square, this part will also come upwards. Here also you will fold, means in between T and S one dotted line, that also you will fold. Here also down B and S, you can see this dotted line, there also one more folding. So you can see all the parts will come up. Clear? If you fold these 4 sides, how does it look? It will look like this cube. So here, this 2-dimensional figure, what we have done, and we have folded it and got this 3D figure, that is a solid. That's why this is the network of a cube. So you have listened. Now you sit and just construct the net of a cube. Now we'll construct the net of a cuboid. So we will take a plain sheet and on that we'll draw this diagram. Here you can see 4 consecutive rectangles. Yes, and on the left and the right side also another 2 rectangles. So the placing or the arrangement of these rectangles will be like this. After drawing, you can color the way I have done. 1, 2, 3, 4 rectangles. I have colored green, and here 1 and 2 I have colored as maroon. You can mark them like this. All the green rectangles, mark it as side, and maroon, the center one as bottom and the extreme end as top. After that, with a scissor, you will neatly cut the outline, the boundary of the figure. As my pointer is moving, you will follow the same path. Next, the work is folding. So how we will fold? look at here the dotted lines. We'll fold one after the other. So look at here, the first dotted line, we will fold in the same direction. If you are doing in the upward, then do all the foldings in the upward. You can do in the downward direction also. But here I am doing in the upward because the bottom and the top I have specified. So here this dotted line, you fold this rectangle, it will come up. Here along with this dotted line, you will fold and this part will come up. Here you can see this small rectangle. If you fold along with this line, this part also will come up. Here this long dotted line you will fold. So entire part will come up. Again you have to fold one more. So as per my pointer you can see and please fold it. As you will fold it, you will get the shape of a cuboid. So here we have drawn the diagram on a plane. So it is a two-dimensional figure. As we will fold, it will convert into a three-dimensional figure, and that is here a cuboid. So that's why it's a net of a cuboid. Let's see how does it look. So your cuboid will look like this, where the top will be maroon and the bottom also will be maroon and all the four sides will be green. The front and the right side you can see here. Now if you remove all the folding and if you place all the parts, you will get the plain figure what we have drawn, right? So this is the cuboid what you have constructed through net. Here one thing I want to tell, when you are coloring the plain figure, you can color both the sides of the paper. Okay, so when you fold, the color will show from outside also. Now we will construct the net of a cylinder. Look at the diagram here. This is a cylinder. A cylinder is having two circular faces, top and the bottom, and in the middle the curved surface. Looking at this diagram, can you imagine the net of a cylinder? What you have to do? We will draw a rectangle like this. On a plain sheet, you will do. Now on the top and the bottom, you will draw another two circles which will touch the rectangle. After drawing, you can color it also. Then you will cut the outline of this figure. Don't detach these two circles from the rectangle. Do that part very carefully. After that, it comes folding. So here, you know the top and the bottom. I feel you can understand here the circles. Both the circles will represent top and the bottom circular surface of the cylinder. So how you will fold? Here you can see left and the right side of the rectangle is free. So from left to right, you can fold it like a cylinder. So automatically this top circle and this bottom circle will represent as the circular bases of the cylinder. So these two-dimensional figure is representing now a 3D figure, and that is a cylinder. So what these two-dimensional figure we have drawn now and we have cut and constructed a cylinder is the net of a cylinder. Now we will construct the net of a cone. And for that you have to draw a figure like this. And then one more circle just touching of this figure. You know a cone is having a lateral curved surface and a circular base. Here this green part is the lateral surface and this circle is the circular base. You have to fold and give the shape of a cone. Yes, it is a two-dimensional figure. We will fold it and convert it into a three-dimensional figure. So your folding will be from this end, you will roll the paper and this end will come and touch it. So This will be the vertex. This point, can you see my pointer? This point will be the vertex on the top. This is the lateral surface, and the circular base touch that lateral surface, and it will look like this. You will get the shape of a cone. So here what we have drawn and cut this two-dimensional shape has been folded and converted into three-dimensional figure. So this is nothing but a net of a cone. Look at the assignment here. First main, write down the name, number of faces, edges and vertices of each shape. A is a cylinder, B is a cuboid, C is a sphere. Second main, draw the nets of the following figures: cube, cuboid and cone. There are so many figures I have discussed in today's lesson. I have given few of them, but you practice all of them and complete the assignment. Thank you, children.